Example 8.14. Consider the cash flow sequence in the table below. Find out the internal rate of return and create the NPV profile at different rates of discount. We'll use the IRR as one of the ways in which we can create the NPV profile. So in this, we know that the IRR is 35%, so we'll use the NPV profile between 0 and 36%. So let's take these cash flows. They've already been laid out in Excel like this, for example 8.14, and so let's find out the IRR. Equals IRR, these are the values, all of them, and let's guess say 2%. So when we say the guess is 2%, this is why the guess is actually powerful. We get the IRR as 3.58%. Now let's guess again. This time let's guess 24%. So we can see that now the IRR comes out to be 32.24%. And why? The reason for that is actually available in two ways. The first way is there are two inflections of sign. So it goes from negative to positive, and then it's positive, 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 goes negative again, and then positive again. So the project has multiple negative and positive in and out flows, and that's causing the project to have multiple IRRs. In particular, there are two sign changes here, one from negative to positive and again from negative to positive, which is causing these two IRRs. Now let's find out the NPV profile at different rates of interest. So we'll go from 0 to 36%, and so we'll start at 0% and then just keep adding plus 0.02 and then go up, Control C, and then how many are these? So we have 18 of these. So go down and Control V. We need 3 more, 36%. Okay, so this is the rate and this is the NPV, net present value. How do we find out the net present value? Using the NPV formula, equals NPV followed by rate, equals NPV. We didn't put the parenthesis, rate, and this will change as we paste it down, but the values will not change. So values will be all the 9 cash flows. We need to fix them. So $H, $15, $H, $15, colon, $H, $23, and you can see the red has marked these cash flows, and then close that NPV formula plus $H, $14. In this case, it's just going to be the linear sum of all these cash flows. So we'll have to convert these percentages into numbers. Control C, Alt E, S, W. We'll paste the column width. So we've reverted the column width back. And then so just look at the formula. So it's taking these cash flows inside the NPV formula and the 0th cash flow outside. Now we could do it in another way, equals NPV, the rate, comma, all of them times 1 plus the rate will give us the same answer. Control C, Alt EST, Alt ESW. And then just copy that and Control down arrow, Shift Control up, Control V. No, the second formula does not seem to be working. Let's see why not. This is good. Oh, we didn't fix anything here. Wonderful. So fix that. $H, $14, $H, $23, and Control C, Control V. Now the values are all consistent. So both the formulae for NPV yield the same results. In other words, we can use it like this, in which the initial cash flow is added outside the NPV function, or we can keep the initial cash flow inside the NPV function, but we need to multiply it times 1 plus rate, whichever way. So they've both given, to check whether both of them are exactly identical, just take the difference of 2. It has to be 0.0, and it is 0.0. So that means they've got the same results. Okay, that's done. Now let's plot this on a graph. So select, so click here and then shift right, shift control down, alt I, H, and then you'll see this beautiful graph here. Now notice, goes from negative to positive, that's your first IRR, and then positive, 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 goes back to negative, that's your second IRR. So the first IRR is between 0 and 5%, as we saw 3.58%, and the second IRR is between 30 and 35%, which is about 32.24%. And that's example 8.14. So we have two different internal rates of returns in this example, and we have just plotted the NPV profile as shown here. That's example 8.14. Thank you for listening.